Hello everyone, welcome back. I hope you had a good lunch. Uh, I'm sure that uh, the lunch is also one of the attractions of the conference that we usually have in place. This time, unfortunately, that couldn't happen. But I'm sure you had an equally delicious lunch at home. Welcome back. The next workshop is a workshop on Indic NLP, natural language processing for Indian languages using Python, and is being given by Gajendra Deshpande. So please give a warm welcome to Mr. Gajendra Deshpande. And Gajendra, you can start. The stage is all yours. Thank you.
Yeah, thank you. Hello everyone. I will be delivering a workshop on Indic NLP, that is natural language processing for Indian languages using Python. So I don't have much slides. So I have just a few slides which actually describes the features of few libraries. So actually my system got crashed yesterday, so unfortunately I will not be able to show demo of some features, but maximum we can do the demonstration, and even you can have some practice. So basically, as you are aware, NLP stands for natural language processing, and it is used for a wide variety of tasks. So the basic task what we can consider using NLP is text summarization. That is, you will be given a very large document. You'll be given a very large document, and you have to generate a summary of it. So when we say large document, it may have hundreds of sentences. So you may have to extract few sentences from the document, and actually it should be the summary. So basically generating a summary from large documents is one application. Then similarly, one more application what we can think is chatbots, which actually understand the response of a human and gives appropriate response. Then we can also think of application known as text generation. So you'll be given text as input, and it's going to generate based on the text some more text. So that may be related text, or it will be on the same lines of your input text. So that is text generation. So you might be aware that there's a very famous library for text generation, that is GPT-3, which is very much advanced. So we are not going to go for such advanced tasks. So I'm going to keep this workshop very basic, so that you can execute few programs, and you can consider this workshop as a starting point, and you can develop your own applications. So in today's workshop, we will see about introduction to NLP for Indian languages, then installation steps. I have already shared the installation steps, but for the benefit of everyone, I will again show the small demonstration. We will not go for the complete installation. Then next is libraries, Inltk, Indic NLP, and Stanza. So these are the three natural language processing libraries we are going to discuss. Now, when I say installation, there are actually three options. You can follow any one. So first one is you can install on your machine. It may be desktop or a laptop. So you can install all these packages either on Windows or Linux or Mac platform. So you have freedom here, but I'll be sticking to only one platform. The next is using REPL and GitHub. So REPL is a website where you can execute all your programs online. So you need not have to install any software. So all the interpreters and compilers are hosted online. So you just need to create a REPL and start typing the program, and you can execute it. So one more beauty here is that you will be able to execute your programs from GitHub. So you can store the programs on GitHub, import them to REPL, execute them, modify them, then again push them back to REPL. Then third option we have is Kaggle notebooks. So in this workshop, I'm going to use Kaggle notebook as well as REPL and GitHub. That is because the first library which we are going to install, that is Inltk. So it gives some problem on REPL. So on REPL it is not available. So we need to install it on Kaggle notebook. But if you are using Kaggle notebook, you can install all three libraries without any problems. So the easiest setup will be using Kaggle notebooks. So installing Inltk, you need to issue the command or write the command pip install, and it has a dependency. So you need to install a torque library. So this is a major problem whenever we are installing Inltk. So we need to install appropriate torque version. So I suggest everyone to go for Python 3.7 or 3.8 with torque version as 1.3.1. So presently on the systems, many times whenever you install PyTorque or torque, you find that 1.7.1 or 1.7.0 or some higher version is being installed. So you have to make a small change here. Instead of 1.7.1, you should say 1.3.1 or 1.4.0. So the preferred is 1.3.1. So install the dependency. Then once it is successfully installed, you can issue the command pip install Inltk. Then this is about the first library. Then if you want to install Indic library and Stanza, then there is not much dependency. You can just issue the command and it will execute without any problems. So Stanza is a Stanford NLP. So it supports more than 66 languages. We'll see what are those 66 languages. But we are interested in only Indic language support. Okay, so previously it was known as Stanford NLP, but it is now renamed as Stanza. But of course, Stanford and you will also be able to install Stanford NLP and you will be able to use those features. But it is suggested that you stick to Stanza. Now, if we see the ecosystem, natural language processing for Indic languages, we have three main libraries: Inltk, Indic NLP library, and the Stanford NLP, which we are going to discuss, and we will only discuss few features of it. So just for the understanding of the participants, so there are some keywords listed, and I'm going to discuss these keywords in brief. So the first one is tokenization. So tokenization is dividing the document into sentences and words. So we can't perform processing directly. So we need to perform some sort of computation over the text, that is sentences and words. So for that purpose, we need to divide the document into sentences, then into words. So basically, when we perform tokenization, we usually specify the delimiting character. So in case of sentence tokenization, the delimiting character will be full stop, whereas in case of word tokenization, the delimiting character will be white space character. Then second term is word embeddings. So basically what happens here is, in word embeddings, it gives the distribution of words in the document. The next is text completion. So in actually text completion, we try to predict the next few words. So you will be given some 5 words and you need to predict next 5 words or next 10 words based on the previous 5 words. The next is similarity of sentences. So here you need to calculate the similarity score between sentences. So you can compute the similarity using some techniques known as cosine similarity and so on. So it basically tells how close two sentences are. So if the score is high, then you can consider that two sentences are more similar. If the score is less, then you can consider it that sentences are not much similar. The next is normalization. In normalization is very important with respect to Indic languages. That is because we know that uh, our Indian language characters are represented using unique codes, and there are different standards. And when we represent these standards, it may generate a lot of unwanted characters. So we need to remove those unwanted characters and bring the text to normalized form. So this gives us the consistency in processing the text. The next is the transliteration. So there are actually two terms. One is transliteration and second one is translation. So translation is different and transliteration is different. So basically in translation, what happens, there will be an input language and you convert it into some output language. Say for example, I can say that India is an amazing country in English, so that you can translate into Hindi, saying Bharat ek adbhut desh hai. So that's a translation. So actually, you translate from one language to another. In case of transliteration, you are just writing it in another language. You are just say for example, some Indian languages they don't have a script. Okay, so in that case they are written in some other languages, so that's a transliteration. Say for example, I can use English language script to write uh, Hindi language sentence. Okay, so that's a transliteration. The next is phonetic analysis. In case of phonetic analysis, we see how two characters sound. Are they sound similar or they are different? Say for example, if there are two characters k and kh, so they sound similar. But if I say k and g, it is not similar. Okay, so in phonetic analysis we see how two characters sound basically. The next is syllabification. In syllabification, what we do is, again, there is a input word, we are going to generate the output word. When we generate the output word, we are going to divide the word in such a way that there should be a single vowel in it. Okay, so there should be a single vowel in it. So for example, if you consider the word phonetic, so I can divide it into three subwords. Say for example, pho, because a e I o u, these are the vowels in English. So here pho is one term, then ne is another term, and tic is another term. So when we are dividing the words, be it spoken or be it written, so we are making sure that it has only one vowel in it. So in that way we are going to achieve the syllabification. The next is lemmatization. So in lemmatization, what happens is, you have some basic terms, and when we use those basic terms in the sentences, we are going to suffix or prefix some things. So basically it is a suffix. Say for example, if there is a term called as give, then I'm going to um, suffix ing for giving. Then I'm going to uh, append n for given. Okay, so we need to convert such words into their basic forms. Okay, so bringing back the words to their basic forms is known as lemmatization. This is very important, because we are going to perform some computations. Say for example, word frequency. So there we are going to compute how many times each word is occurring in a text. So in that case, giving and given and give, so both all these three words are treated differently if you don't perform lemmatization. Okay, but if you perform lemmatization, then you are going to remove the suffix, that is ing and n, from the word give. So you have now the word which is remaining is give. So now I can say that the frequency is 3. So you are converting the word to its basic form in lemmatization. The next is part of speech. So now we know that whenever we are dealing with the language, the important factor is again the part of speech. So you can identify the different words along with their part of speech. You can identify a word as a verb or a noun and so on. Then next is named entity recognition. Now again, when we have a document, we are going to reference several things. We may refer an organization, we may refer a place. Okay, so these needs to be recognized. So that can be achieved by using named entity recognition. The next is dependency parsing. In dependency parsing, we are going to perform grammatical analysis, how two words are dependent, how two sentences are dependent, and so on. So these are the basic terms which we are going to see, or whenever we are writing a program, whenever we are executing a program, we are going to use these terms. So the first library is Inltk. So that is Natural Language Toolkit for Indic languages. So it is created by Gaurav Arora. So he has a paper also. If you Google, you will get the PDF of the paper. Apart from that, there is very good resource also available for Inltk libraries. So the links are mentioned on this slide. So Inltk aims to provide out-of-the-box support for various NLP tasks that an application developer might need for Indic languages. So those features we have already seen in the previous slides. They are tokenization, sentence similarity, and so on. Then it supports native languages as well as code mixed languages. So by native languages, we mean our natural languages, that is Kannada, English, Hindi, Marathi, Tamil, Telugu, Malayalam, and so on. Then similarly, when I say code mixed languages, it is the combination of two languages. So for example, we can refer to English as a combination of Hindi and English. And similarly, we can refer to Manglish, which is a combination of Malayalam and English. So it supports few code mixed languages also. So Inltk is currently supported only on Linux and Windows 10 with Python version greater than 3.6. Okay. So the next library is Indic NLP library. So you can see here it supports some features. It supports Indo-Aryan languages, Dravidian languages, and other languages. So in case of India, we know that languages are divided into two classes here, Indo-Aryan and Dravidian. So it supports around 12 Indo-Aryan languages, including Hindi or Urdu, Marathi, Nepali, then Punjabi, Konkani, Sanskrit, Sindhi, Simhala, etc. Then in case of Dravidian, it supports four South Indian languages, Kannada, Malayalam, Telugu, and Tamil. Then in others, it supports English language. And you can also see here that some features are also mentioned. So which feature is supported by which language, that is uh, mentioned here. If you refer the table, it will be clear to you. So mostly in case of South Indian languages or in case of Dravidian languages, all features are supported, but some features are not supported in case of few Indo-Aryan languages. Say for example, only tokenization is supported in case of Urdu, and word segmentation is not supported in case of few languages such as Nepali, Assamese, Sanskrit, and Sindhi, and so on. So it also supports bilingual features, that is script conversion is possible, as you can convert from one language to the another language, and transliteration is possible, and also the translation is possible. And if you want more information, then you can refer the URL which is mentioned on this slide. Now the features of Indic NLP library are that again we have already seen the features in our previous slides. It is created by Anup Kunchukutan. Then the goal of Indic NLP library is to build Python-based libraries for common text processing and natural language processing in Indian languages. The advantage in Indian languages is that it shares they share a lot of similarity in terms of script, phonology, and language syntax. And Indic NLP library tries to address uh, these these things, and you'll be able to develop the application. So the major advantage here is that uh, major advantage is the bilingual features. So that is transliteration and translations between the languages is possible. So similarly, you can refer to these resources. Of course, we will be looking at these resources later. Then the third library which we are going to discuss is the Stanza. So it is earlier known as the Stanford NLP. So it's a Python NLP package for many human languages. Stanza is a collection of accurate and efficient tools of many human languages in one place. So it starts from raw text to syntactic analysis to entity recognition. So it brings state-of-the-art NLP models to languages. Then native Python implementation requiring minimal efforts to set up. Then full neural network pipeline for robust text analytics, including tokenization, multi-word token expansion, lemmatization, part of speech and morphological features tagging, and so on. So pre-trained neural models supporting 66 human languages is available. And in case of Indic languages, it supports Hindi, Marathi, Tamil, Telugu, and Urdu. So those who want to contribute with respect to open source, you have a lot of scope here. You can improve the existing features of the mentioned languages, and also you can add the support for your own language. And it is very stable. Yeah. So there is a website called as stanza.run. You can visit stanza.run and you can see the demonstration of Stanza library. So you can provide the input, select the language, and it will show the output. So later on we can see the demo also. Okay. So as I have said, we can go for either REPL. So if you go for REPL, then you will not be able to work with Inltk. So just I will introduce the few features of REPL. So the first step is you have to create the account in REPL. Then you have to create the account in GitHub. So I have already shared the resources. You can fork the library. So some source codes have been uploaded in the resource. So when you fork it, you will get the copy of all the programs into your repository. Then in REPL, once you create a REPL, you can install the packages here. So there is an option here, packages, and you can start searching for a package. So if I want to install, say, Indic NLP, so you can see here that it shows the list, and if I click here, then it's already installed, so it is showing the minus symbol here. But if it is not installed, then it will show the plus symbol. You need to click on plus symbol. So when you click on plus symbol, you can observe that on the right hand side you will see the package being installed. So in this way you can install the required packages. Then this is the link where actually you need to link your GitHub repo. So it's already linked, so I can directly access all the files here. But if it is not linked, then it will open a small window here, and you need to specify the URL of your GitHub repo. So once it is uh, linked, you will find all the programs here. So you can see here it is already linked. So on the left hand side you can see the programs here. So you just need to click on it, and there's a run button. When you click on run button, you will see the output on the right hand side on the black screen. There is also a middle section where you can actually start typing the programs, or you can directly open the program from your forked repository. So this is one option. So you will be able to install Indic NLP library on REPL, but Inltk there is some problem. So the better way is to go for Kaggle notebook. So you can just open Kaggle notebook here. So you have to create an account. That's a prerequisite. So once you create an account, you can click on new notebook, and you can see here that there's an option to select a language. So two options are available. One is Python and second one is R. So stick to Python and click on create. It will create a empty notebook here. And there are some settings you need to make. So first one is the accelerator. You need to set accelerator, and second one is you need to enable this option internet. So to enable these two options, it will ask for a verification. Maybe you may have to enter a mobile number and you will receive an OTP. And once you enter the OTP, your Kaggle account will be set up. So once everything is done, this is how your Kaggle notebook will look like. Okay. So the first step is to install the Inltk library. So to install Inltk library, we need a command. So that is yeah. So we need to copy this command and execute. So I'm going to make a change here. I'm not going to use Torque version 1.7.1. I'm going to use 1.3.1 here. So if you have worked on Jupyter Notebook, you will be able to use it without any problems here. Otherwise, you can click on plus button. It will add a code section here. So just paste it here. Now note here that when you are working in Kaggle notebook or any notebook, you need to add exclamation mark. So that's a syntax to install any commands. So note here that I have made the change here. So instead of 1.7.1, I'm using 1.3.1. So either you can click on this blue play button or just enter Control Enter. So it will download and install.
Mr. Gajendra,
Yeah.
it looks like the text is not completely visible. Is it
Okay.
possible for you to increase the
Yeah.
font size a bit?
Sure. Sure.
Second, I'll also
Yeah.
verify.
Now is it okay?
Just 1 second. I'll just
Yeah.
switch to full screen to make sure that.
Yeah.
I also verify. Uh, yes, this seems good.
Yeah. This is okay, right?
Yes, this seems good. Yes.
Yeah. Yeah.
Okay, right. Uh, okay, so what was a few people are asking what was your last command?
Okay.
Uh,
Yeah. I will explain the Kaggle notebook once again for those people.
yes, yes.
Yeah. Yeah. So Kaggle is the simplest way where you can set up your environment for this workshop. You will be able to install all three packages without any problems if you go for Kaggle. I've already explained the alternative approaches, but that may take some time for you to configure. But better is to go for Kaggle. So you need to create an account in Kaggle basically, and when you create an account, you can create a new notebook. So let me repeat the steps once again. Yeah. So once you create an account, you will see similar kind of interface here. So some options may not be visible to you because I have increased the font size for visibility purpose. So you can click on new notebook option here. So once you click on new notebook option, it will open yeah, this window where you can actually select the language. So by default, Python is selected and by default notebook is selected. So let the default options as it is and click on create button. So you are seeing the message here, session is starting, and it also loads some default script. So don't worry about it. So just let it be as it is. But you need to make some configuration here. That is, you need to add the accelerator and you need to enable internet option. So that you will see on the right hand side when you create this notebook. Now to do that, you need to verify your Kaggle account. To verify your Kaggle account, it will ask your mobile number. When you enter the mobile number, you will receive an OTP. So you need to enter the OTP and verify. So your Kaggle environment is ready for work. So the first library which we are going to discuss today is Inltk. So we need to install it. So to install it, we need a command. So that command you will find in my GitHub repository. So the GitHub repository is github.com. So just for a reference, I'll put it here. Yeah. So this is a GitHub repo. So you just scroll down on this repo, you will find the commands which you need to use to install the libraries. So either you can click on plus code here or you can click on plus button here. It's fine. Now go to this repo, scroll down. I will again increase the font size here. Okay. So you need to copy this first command. Okay, which installs the dependency for Inltk library, that is Torque library. I'll say copy, and I will add exclamation mark. Note here that whenever you want to install any software or any package in Kaggle, you need to first mention exclamation mark. That's a syntax. Then write the command. So I have pasted the command here. Now I'm not going to use the recent Torque version because it may raise some compatibility issues. So I'm going to stick to the lower version, that is 1.3.1. So this is the command. So I will just keep it for a few seconds for you to note down. So the command is exclamation mark pip install torque double equal to 1.3.1 plus CPU minus F and the URL. Okay, so this will install uh, torque 1.3.1. So to install it, you need to run this command. Okay, so that is very, very important. So to run this command, either you can click on this play button. That is, you can see here it says that run current cell. Okay. So you can click here also, execute cell, or you can use a keyboard shortcut Control Enter. Okay. Yes. So now it has started installing. So it will take time if you are having slow internet connection. So note here that it is installing the current version, that is 1.7.0, and it will install the 1.3.1 version. So same thing you need to do on your PC also. So Python 3.7 and PyTorch 1.3.1 will successfully install Inltk on your machine. If you are getting some error messages, don't worry. So you need to just concentrate on this message. So here we are getting the message, successfully installed Torque 1.3.1 CPU. So once this is installed, we need to install Inltk library now. So again, I'll say exclamation mark pip install Inltk, control enter. Yes. So even this library has been successfully installed. Now again, I'll add a code cell. Now the first command we need to run is to download a language model. So we know that Inltk has different language models. So if I go to the tutorial here, that is the official documentation of Inltk library. So you can see here that it supports these many languages: Hindi, Punjabi, Gujarati, Kannada, Malayalam, Oriya, Marathi, Bengali, Tamil, Urdu, Nepali, Sanskrit, English, and Telugu. So you can install any language model. So if you know any of these languages, you can work on that. So I strongly prefer that. Uh, I may be sticking to the examples basically for Hindi language. That's because many people can understand it. But if you know Kannada, or if you know Marathi, if you know Tamil or Malayalam, you are free to use that language. So nothing much. So you just need to change few parameters, and you will be able to perform NLP for your own language, for your mother tongue. Yeah, and also it supports code mixed language, as I have said. So this is the first command which you need to execute. That is, you need to import the setup module here. So I have already mentioned this, or there are some scripts are also present here. So let's click on GitHub library here. So there are some scripts written. So there's a script written setup language.py. So don't run this file because this is very generic. It is going to download all the language models and it will be in terms of GB. So don't execute this. But just for demonstration purpose, everything is mentioned here. So you can choose only one or two from this list. So for example, there's a script known as script language.py. So if you want to work on Hindi, then you need to go to this URL that is inside the GitHub repo, go to Inltk, then you click on setup language hindi.py. Okay. Then copy these two statements. Then come back to Kaggle, paste it here, and run it. So it will take some time to download. Now note here that if you get some warning message or this, don't worry, just ignore it, it will work. Now note here that every language model is downloaded for the first time. Okay, once it is downloaded for the first time, you do not have to write it again. So you can, whenever there is a need, you just need to comment it and go on writing the other statements. Now you can see here there's a done message, and also it has given the message here that downloading model, this might take time depending on your internet connection, please be patient. We will only do this for the first time. Okay, so only for the first time you need to set up the language. So we want to work on Hindi language, so I'm saying here Hindi. So setup of HI. So HI is the code for Hindi. So similarly, I may prefer to work on some other language, say Kannada. So I will write one more statement here. I'll click on plus code. I will write setup and KN. So KN is the code for Kannada language. Yes, done. So now I will be able to perform processing on these languages. So similarly, if you want to work on your mother tongue and if there is support for it, I strongly suggest go for it. So this is about setting up the environment and downloading the language. Okay. The next file you need to examine is the tokenize.py. Now note here that tokenization is very important task which we are going to perform. So tokenization is not so simple. It's a very basic example which we are going to discuss. Of course, whatever example you are seeing here, it is also available on the tutorial. So most of these examples are available online. So we can execute these programs and start making the changes. Say, for example, on this code, you can see here, on the first line, we are importing the tokenize module. Then we have defined a variable Hindi text. Then we have defined a string, which is of course multi-line string. Then we are saying that tokenize Hindi text, it's a variable name which we have defined here. Then this is the language. So language code is HI because this is a Hindi text. So let us execute this. Okay, copy, then plus code, paste it here, then run it. So you can see here it has performed tokenization. So it has basically performed word tokenization. It has returned a list as the output, and you can see here that they have been separated with a comma, and it is basically a strings list. And you can also see here that there is a white space added before it. Okay, so this is how you can generate the tokens. Now let us generate the tokens for other languages. So what I'll do is I'll copy this text, Control C, I'll open a new window, then I'll say here Google Translate. So it's a Hindi language. So I'll select some other language here. say for example I will select Kannada, so you can select any other language, no problem. So you can, so now we have two things. One is the source language, which is Hindi, and there is another language which is Kannada. So destination language is Kannada. Now what I'll do is I'll copy this text. Okay, so before copying the text, again, this is a great example where I can discuss transliteration and translation. Now you can see here there are two scripts. One is Hindi and second one is Kannada. So we are translating from Hindi to Kannada here, but you can observe this part. Okay, this is the same thing which is mentioned above in Kannada. Okay, so I can read it in the same way. So this is transliteration. Okay, so I will copy this text. Then again I'll come back to Kaggle here. Then I will replace this text. Okay, then I need to make few more changes also here. I have already loaded the Kannada language model, so I just need to mention n here. Now when I run it, so you can see here the same output. Okay, only thing is language is different and script is different. Okay, but without any problems we have got the output. Okay, we have just done two changes. Just replace the text in Hindi text here. So you if you want, you can rename this variable also. For better understanding. Done. Okay, so the same thing you can do it for your language. You need not have to search for any sentence, just go for Google Translation, provide this existing statement, translate it, copy it, and use it in your script. So this is about tokenization. Then next one, the next one we'll go for is identify language. So the file name you need to refer is identifylanguage.py. So this is the file name you need to open. Okay, so again it's a very small script. So from inltk.inltk import identify language module. Okay, then you need to use a function identify language, that is specifically identify underscore language, and specify input. So here the input is mentioned as Bharat ek adbhut desh hai. So I will copy it. Then I will paste it here. Then let's click on run. Okay, some problem here. So it should actually return the statement Hindi. So you can try in your notebook, see if you are getting the output.
Seems to be something related to the Kaggle notebook, is it?
Yeah. Yeah, fine. Uh, yeah, some error, but in this case, it's going to return Kannada. So you can test on your notebooks if you're getting fine. Otherwise, it's okay. So not a problem. So we can go to the next uh, code block. So next code block is similar sentence. Okay. So this is a interesting code. It's a small code. So in the first line, we are importing the module get underscore similar underscore sentences. So this is the module which you need to import if you want to generate or if you want to get similar sentences. So in the second statement, we have defined a variable output and we are using a method get underscore similar underscore sentences. Now it takes here three parameters. So first one is the input text. So I have directly mentioned here Bharat ek adbhut desh hai. Then how many similar sentences you want to generate. Then in which language you want to generate. So here I want to generate 5 sentences which are similar to Bharat ek adbhut desh hai in Hindi. Then finally print it. So let's copy this. Paste it here and run it. Yes. So you can see here it has generated 5 statements, okay, which are similar to the previous statement. भारत एक अद्भुत देश है. भारत एक अद्भुत देश है. Then भारत एक सर्वोत्कृष्ट देश है. So you can see here it has added a new term. It has replaced अद्भुत with सर्वोत्कृष्ट. Then again remaining statements are same. So let's modify this. Maybe let's try to generate more sentences. I will make it 10. So it may not be visible, so you need to scroll a bit. Yes. So it is also visible in the console. Okay. So you can click on console also here if you want to see the output. So you can see here when we have changed the number of sentences. So in case of instead of 5, when we mentioned 10, we are actually getting the better output. So you can see here now it is saying अप्रतिम देश है, बेजोड़ देश है, सर्वोत्कृष्ट देश है, अद्भुत देश है, अद्भुत राज्य है. So it has now replaced the term desh with rajya. Now it has also replaced he with the. Okay, yeah, and also it has mentioned desh with rashtra. So you can see here that it has generated 10 similar sentences. Okay, so similarly, if you want to make one more experiment, then again do it with respect to your language, because I believe that that's the best thing to do, because you understand the grammar better. I don't understand the grammar of Hindi actually, although we have studied it in schools. I will mention the statement. I will make this change. Okay. So I've added a small sentence in Kannada, then number of sentences are 10, then language is Kannada. Actually, you can mention sentence which is long. So that will be very interesting to see. Yes. So I have got some interesting things. So it says that, so it's the same sentence which we have added in Hindi. So in Hindi it is says that Bharat ek adbhut desh hai. In Kannada it is the same thing, Bharat adbhut desh. So that is sufficient. So it has even replaced the country names like from India to Australia and so on. But it has added few keywords like it has replaced Adbhut with Advitiya, Mahonnat, Arthapurna, and so on. So, so the more the statements and more the length of the statement, you will get the interesting outputs. So you can just try it. So you can just try it. I'll just take just 2 minutes break. I'll just take. So I'll be back in 2 minutes. Okay, I am back. So let's go to the next example. So next example is the sentence similarity. So what we have done earlier in our earlier example is we have generated similar sentences, but now here we are going to check whether two sentences are similar. So again here in the first statement, you need to import a module get underscore sentence underscore similarity. Then you need to use this function directly, get underscore sentence underscore similarity. So it takes three parameters. So first one is the first string, that's the first sentence. Second argument is the second statement. Okay. And third one is the language. So let's check about this. Okay, it says invalid syntax here. Yes. So you can see here that it has given some number, that is 0.79%. It is similar. So that means it is 79% similar. So if you change the statement, you will get a different output. Now again, let's make changes to this statement. We'll copy this. We have already this statement. So paste it here. And we'll copy the second statement. We'll paste it here. So I'm not getting the accurate statement here. Okay, fine. We'll check. Okay. So now we'll check the similarity. Okay, so the similarity has been reduced. That's because I'm getting some English characters here. So I'm not able to translate it correctly. Yeah. So it should be interesting when we translate the same thing into other language exactly and see are we getting the same output. If we are not getting same output, then that should be interesting. Why we are not getting the same output. I need to change here. Okay. Okay, still it is reduced because of some corrections. Yeah, fine. So it will be interesting when we exactly translate and see are we getting the same score when we compare two sentences. Yes. Okay. So you can also try it with your mother tongue language. So let's move to the next example. The next example is embedding vectors. Okay. So basically in embedding vectors, we are going to get some numeric output. So that numeric output, you can use it whenever you are building a neural network or deep learning model, because you can perform lots of computations on numeric things compared to the text output. So basically here we are converting to text to vectors. So again, you need to import get embedding vectors module and pass the string as input, specify the language. Then here we are printing the dimension. So this dimension is bit huge. So let's execute this. Yes. Okay. So you can see here we are seeing some numeric output. Okay. So there's actually some mathematical formulas which will be applied over this text, input text, and these numbers have been received here. This is the dimension 400. So next is remove foreign language. So you can refer this file, remove foreign lang.py file. So this is again a very simple example. You need to import the module, what is remove underscore foreign underscore languages. Then use a function remove underscore foreign underscore languages. Then specify a large string which is actually the mixture of several languages. Okay. So for example, you can see here there is a Hindi text, and I think there is uh, some Assamese or Bengali text, then some Chinese text again. Okay, so it's basically a single string which is mixture of several languages. So when we execute this program, it should remove all other languages except Hindi. So let's do this. Control C. Okay, so you can see here we have received the output. Okay, so what it has done is it has kept only Hindi text and it has removed all other text. Okay, so the text which is mentioned in maybe some other script. So I don't know exactly what is that script here. So it has removed this part. Okay. Okay. Then similarly, it has also removed this Chinese characters. Okay. So wherever those characters were present, wherever those words were present, it has replaced those words with UNK. So stating that it's a foreign language term and it has been removed. Now note here that by foreign language we mean it's not uh, the language outside India, it's the language other than specified here. So in this case, except Hindi, everything is a foreign language. Okay. So similarly, we can actually do this. So copy and we'll paste the code here. Okay, so now you can see here that this text actually has some got English letters. Now I will specify it as Kannada. So yeah. Okay. Again, there is some strange output. It has not removed English, but it has tokenized it. Okay. So maybe we need a appropriate statement here. Okay, so some problem. Yeah, fine, not a problem. Okay, but you might have observed in the previous case that except Hindi, it has removed all other characters. So that is remove foreign language functionality. Okay, then next example. Okay, so next is text complete example here. So in this example, what it does is it is going to predict next words. Okay, so again here we are importing the predict next words module. No need to actually run this because we are working on Hindi. So just this statement is sufficient. So let's execute this one. I don't need this statement. Okay, so you can see here it has written this statement Bharat ek Adbhut Desh hai as it is, and after that it has generated 10 words. Okay, you can mention these words and it's going to generate those many words. Okay, so the first parameter is this string, second parameter is how many words you want to generate, the third one is the language, and fourth property is the randomness. So by default, if you don't mention anything, it will be pointed, but of course you can change it. So let's see how it will behave. So now it has generated some other output. Okay, so similarly you can do this experiment with some other language also. Okay. Control C. Let me generate statement here. Okay. Yes. So it is basically generating 20 words randomly. So this is the example of text generation. So we have a very sophisticated algorithm such as GPT-3 in case of English language, which can actually generate very sophisticated output. So this, you can consider this as a very small version. Even this example, predict next words and even generate similar sentences. So these are the smaller examples, and these are not accurate examples. Okay, so these are the examples of Inltk library. So let's move to the next library, that is Indic NLP library. So we have got some examples here also. So you can execute the same in so to execute them on Kaggle, you need to install the library here. So to install it, you need to say exclamation pip install Indic NLP library and control enter. So it will install this library here. Yes, it has been installed successfully. Let's execute the first example. So first example is always the tokenizer. Okay, so this is the example for word tokenizer. So you have a sentence here. सुनो कुछ आवाज आ रही है phone, and again as usual you need to import the respective modules. So in this case I'm importing indic underscore tokenize module, then define an index string, right? Then finally print it. So I'm not storing it, I'm just printing it. So to tokenize, you need to use the method which is available in Indic NLP, that is trivial underscore tokenize, and pass your input string here. So it will tokenize. Control C, Control V. Yeah, so you can see here this output is more clean compared to our Inltk. So same output you can get when you execute this program on REPL. So next example, this is interesting example, detokenization. So we have seen tokenization example where we have divided our we have tokenized this sentence into words, but this is another example where we are going to tokenize words into sentences. Okay, so this is the other way. So we call it as detokenize. So you can see here we have some things mentioned in double quotes here, right? Then this is the entire string which is mentioned in the single quote. And to detokenize, where we need indic underscore detokenize module and trivial underscore detokenize method. Okay. And note here that you also need to specify a language. So language code is Hindi. So if you want to do the same thing for Marathi, then you need to say MR. If you want to do it for say Punjabi, then you should say PA and so on. So let's execute this one. Yes. So you can see here when you compare the input string with the detokenized string, it has removed extra spaces in the output. So you can observe the extra spaces here in between in input string, and when we detokenized it, those extra spaces have been removed. Okay. Now this is a single statement. Then next is next is sentence tokenizer. So whatever example we have seen just now, it's a word tokenizer. Now we will discuss about sentence tokenizer. So you need to import sentence underscore tokenize module, then define a string here. Okay, so define a string, then use the method sentence underscore split. This is the input string and this is the language. Okay. And finally here we are printing. So we are printing them directly, but for processing you need to store it somewhere, maybe in a list or some other data structure. If it is huge, then you may store it in file also. So let's copy it and execute. Let's run it. Yeah. So you can see here every sentence has been printed on a new line. Okay. So this is sentence tokenization. Let's do it for some other language. Okay, copy and paste here. Okay. Okay. So we need to set the language. So unlike INLTK, you need not have to download the language models separately. So you just need to mention here. Okay. So let's run it. Yeah. So you can see here that it has tokenized the sentences. Okay. So this is about sentence tokenization. The next is transliterate. So what this code does is First, it's going to import the Unicode Indic translator module, then define the input string. So you can specify any string you like here. Then it's going to represent the same statement in Hindi in Telugu script. Okay. So in Telugu also, if you read it, it is read as आज मौसम अच्छा है, सूरज उज्जवल है और बारिश के कोई संकेत नहीं है, इसलिए हम आज खेल सकते हैं. So only thing is the script will be Telugu, but you will be representing the same text. Control C. Yeah, so you can see here. So I can read it a bit because Kannada and Telugu scripts, they look bit similar. So the first one I can say that it's Aj. Okay, the script is Telugu, but it's the same Hindi text. Okay, so this is about transliteration. And next is okay, phonetic properties. Let's check this. So in this code we are checking the phonetic properties of a character. So first we have defined a character ka in Hindi. So language is Hindi, and we are checking, is it a vowel, is it a consonant, is it a velar, is it palatal, is it aspirated, is it unvoiced, and is it nasal. Okay, so let's copy this and execute.
We have about half an hour to go.
Yeah, sure. I can complete it. Yeah, thank you. So you can see here that is it a vowel? It says false. Is it consonant? Yes, it's consonant. True. Is it velar? It says true. Is it palatal and aspirated? False. Is it unvoiced? It says again true. Is it nasal? False. So ka is same in all the languages. So these properties will give you same output. So even you can check for any other character in any other language, basically. Yeah, so I will just copy one letter. It's the same thing, same output. Okay, so we can also check for vowel. That's fine. So we have checked it for consonant. So you can check it for vowel. So that's about phonetic properties.
A few questions that people are asking.
Yeah.
Would you like to take them now or right at the end?
After this Indic NLP, I can
Okay.
take. So maybe after 5-10 minutes, we can take up the questions.
Okay.
So this example is about vowels. So this is an important example which I would like to discuss. It is a bit long, but we can discuss it. Not a problem. So what we are doing here is we are basically performing tokenization. So these are the prerequisite steps. Whatever things we are performing in this example, these are the prerequisite steps whenever we want to generate the summary. So when we generate the summary, there are actually two types. One is abstract to summarization and extract to summarization. So this is the example for extract to summarization. In extract to summarization, what happens is you will be given a long document as an input, and from that document you need to extract only few sentences. Now you cannot uh, directly extract few sentences. You need to perform some computation over the document, and you need to identify uh, the statements. Now to do that, you need to perform tokenization, then you need to perform word frequency analysis, then you need to perform sentence score, and so on. Of course, in this example, we are not performing sentence score. Okay, so again, in the first line, I'm importing the Indic underscore tokenize module. Then I'm also importing counter module from collections. I need it because I want to count the, I want to find out the word frequency. Okay. Then this is the index string. This is our input string on which we are going to perform some operations. Now, it is very, very important to define the stop words. You need to remove the stop words from the text because they are of no use. Each language has got its own stop words. Okay. It is not only about stop words, you also need to perform lemmatization. You also need to remove some unwanted words which are out of context. If you don't need some words uh, in that particular context, you can simply remove those. So all those things have to be specified in stop words. Actually, you get a stop words list in the internet. Yeah, so this is the URL. Okay, if you go to this URL, you will find all the stop words in Hindi language. I don't know whether it is complete. There are around 225 stop words which are defined. Okay, so these need to be removed. So by removing these stop words, you are also ensuring that you don't unnecessarily process the unwanted data. Okay, and also note here that you also need to remove punctuation marks like comma, question mark, and some numbers if there are. Okay, some special characters. So all those unwanted things you can remove. Then once you remove all those things, then you can perform tokenization. So here we are performing word tokenization. So in this statement, actually, I'm removing all the stop words. Then next is word frequency of grams. So now I'm using counter method on the list to get the frequency of each word in the list. Now since I want top n words, I am sorting them in a reverse order. Now there is a concept called as n-gram analysis. So in n-gram analysis, what happens is we start with a single word, then we go for bigram, trigram, and so on. So bigram is the word frequency when we take the bigram is nothing but, or any n-gram is nothing but the frequency of co-occurring words. So bigram is frequency of two words occurring together. Okay, similarly, trigram is three words occurring together. Okay, if there are five words in a sentence, then we'll take first three words in the first case. In second case, we are going to take 2 3 4. Then in the third case, we are going to take 3 4 5. So in a 5 word sentence, we are going to actually get three trigrams. Maybe you can go for other combinations also and you will get more. So after this, you need to compute the scores of a sentence. Then based on the sentence score, you need to extract top n sentences. When you extract top n sentences, actually you have generated a summary of a document. Okay, so let's execute this and see the output, what we will get. Okay, so let's run this. Okay, so you can see here we have generated, or okay, the tokenization has been performed. Now this is a list before removing the stop words and other symbols. Okay, now this is the list after removing the stop words and symbols. So in this case, you don't find the vertical bar and a question mark. So I forgot to mention comma, so you are seeing it here. So next, this is the word frequency. So Sunoy is appearing for one time, comma one time. So basically all terms are occurring single time here. Then top 10 grams. So since all are occurring for just one time, there is no question of getting top 10 grams. Yes. Okay. So now you can see here, this is about bigrams. So it is checking the combination of suno and comma and kuch, then kuch and awaz, then awaz and so on. So similarly, you can compute trigrams, then 4 grams, n grams, and so on. Okay, so this is about Indic NLP library. If you go to Indic NLP library's documentation, you will find more examples. The thing here is that you need to configure it on local system, because there are some resources which needs to be configured. Okay, so if there are any questions till this point, I can take it up quickly and we can briefly just discuss Stanford NLP library or Stanza library.
Yes. So I guess we have about 20 more minutes, so you have quite a bit of time.
Yeah.
You have a few questions if you've seen them in the stage chat in Hopin.
Okay.
Nitin Jose has been following your talk quite closely. He's been trying a few things out as well. So he's asked whether sentences are identified by full stops. That is his question.
Okay, so in India, if you consider Indic languages, then it depends on the language. So if I say Dravidian languages, it is full stop. In case of Hindi, it is vertical bar. In case of Marathi, it is vertical bar.
Correct. In terms of, so just as a continuation to that question, in terms of techniques,
Yeah.
while sort of analyzing the sentence or multiple sentences, does the algorithm or the function itself consider full stops per se, or does it look at other things like tokenization and stuff like that to sort of distinguish between sentences, or find other meanings out of that? Or is sentence full stop, either the bar or the full stop, the only way to sort of look at?
Uh, in case of tokenizing the sentences, it is just the full stop and a bar. It is just purely a text processing
Okay.
technique.
Okay.
So in order to extract the meaning, then we need to go for some other techniques, some advanced algorithms,
Okay.
maybe machine learning, deep learning models.
Okay.
Yeah.
The second question is by Dr. T. Shankar Rao. He asks how to check a word's probability in a text. I'm not sure if this is directly related to your talk, but I guess he just wanted to know. Uh,
Uh, Words probability.
so,
Uh, yeah.
so I guess obviously, if the word already exists in the you know in the whole wall of text, I guess that would be easy. That I don't think that needs a lot of advanced processing.
Yeah.
But I guess
Yeah.
I don't know.
Uh,
I could sort of extrapolate that he's trying to ask if you can. I think you also spoke about this where it tries to predict the next word or the next
yes.
possible word that could come.
Yes. Yes. Yes, that is purely based on randomness. But with respect to probability, we can consider word embeddings, which actually represents the words into vectors. When we are representing it as a vector, there is some numeric thing we get. So that can be used in neural network models for further computation. And the most basic one is just the n-gram analysis. We just get the count of occurrences of words.
Correct. Yes. So yeah. So he tries to give an example saying like
Mm,
like the word the in a text. So I think that is a matter
mm,
of just counting the occurrences of the word in a wall of text.
yeah.
And I don't think
And
that would be very complex, to be very honest.
yeah, yeah,
Uh,
that's not a complex. And I think there are some words which actually need not to be considered. We consider some words as stop words. Those needs to be straight away removed.
Correct.
Yeah.
The last question that I received for this session was by Kinjal Mistry, and she asks, "Why is underscore unvoiced function used? Like, what is it used for? Why is it used?"
I think in case of phonetic analytics, right?
Yes, I think so. You were just
Yeah.
talking about this before.
Yeah. Phonetic analytics.
Correct.
To be honest, I don't have answer for this question.
Correct.
Uh, yeah,
No problem. No problem.
yeah,
That's it
yeah.
in terms of the questions that we had.
Mm, mm.
I think you had just one small portion, and we have 15 minutes, so you can cover that.
Yeah. I can cover that. So the next thing I would like to cover is the Stanford NLP library. So actually on GitHub, both the versions are available, Stanford NLP as well as Stanza. But we are going to stick to Stanza because it has been renamed now and it has been used as Stanza now. Okay, so to install it, you just need to execute a command here. So again, uh, exclamation mark, install Stanza, control enter. Yes, so Stanza has been successfully installed. So there is a code example actually which we will discuss. Okay. So if you observe the code structure, it looks almost like Inltk, and the process is the same. So in the first step, you need to import the Stanza library. Then you also need to import language model. So here we are downloading Hindi language model. Then next step is to build a language processor. So you need to use a pipeline method for that, and you also need to make use of some uh, properties. Say for example, when we say language processors, you need to specify that we want to perform tokenization, we want to perform lemmatization, we want part of speech tagging, then we want dependency parsing. So these are the things which we want to perform in the pipeline. So those are specified as parameters to processors. Again, these operations will be performed on Hindi language. Then next is, this is our input text. So it's a NLP object you need to create. So just like if you have worked on Spacey library, uh, you may be aware that we create NLP object there. So it's the same thing here. So it's a function which we have created, HINLP, which takes Hindi language text as the input. Okay, then print it. Then similarly, here we are printing the different properties. Say for example, we are printing word tokenizers, then word which is in a lemmatized form, then part of speech tagging, and so on. Then similarly, we are printing entity type and entity text. Then finally, we are printing the output. So let's see how this works. It's going to take some time because it needs to download the Hindi language model. So you can see here, there is only one sentence, and these are the different attributes. This is the word tokenization. Then this is part of speech tagging. It is saying that it is adjective, this is noun, and so on. Then similarly, entity recognition. Okay, so it has performed some more operations here, such as lemmatization on some strings. So also some more properties are being displayed. Okay, so this was a very simple example to print more advanced features of a sentence, such as part of speech tagging and lemmatization. Yeah, and so on. So I have, I think, last 5 minutes left. So let me do something. Okay. So I will open one article here. I'll copy some sentences. This is a website where actually you can see the demo of Stanza. So the website is stanza.run. It's a very simple interface here. Just paste the text. So I have pasted some text from the website. Okay. Then I will select the language Hindi here. Click on submit. Yes. So you can see here it is giving more sophisticated output. So it has identified the part of speech. Then it has identified the lemmas. Then it has also identified the named entity recognition. It says that any NER is not available for this language. So this is the open opportunity. If anyone wants to contribute, they can contribute here. Then universal dependencies. So this is the dependency graph of this text. So this was the demo of stanza.run, that is Stanford NLP library for Hindi. So it also supports some other languages, as I have already told you. Out of 66 languages, it supports 5 Indian languages. So Hindi, Marathi, Tamil, Telugu, and Urdu. So these are the languages supported. So you can also try for some other languages if you want. So this is the output you get when you run your code in Stanza. Yeah. So thank you everyone for attending the workshop. I thank SciPy organizing committee for giving me an opportunity to present the workshop at SciPy India 2020.
Hey Gajendra, thank you so much. Good talk. Uh, it's really interesting to see Indic languages in collab in conjunction with technology like natural language processing. So that was definitely
Yeah.
very interesting. So I guess the stage is open for questions, if there are any, and that's pretty much it. Nitin asks us which library is better for Indic languages. Uh,
Yeah, that's a good question. So I cannot say that this is going to be the best library. So we need to see what we want to achieve. Based on that, we can select a library. Because if you have seen Stanza, which is by Stanford, but named entity recognition feature is not available there. But if that is very much needed, then that's not a great choice. So you have to go to some other library. It clearly depends on what you want to achieve.
correct, correct. Um, okay, then. Thank you so much,
Yeah,
Gajendra, for the talk. And I guess if there are no more questions, we can sign off and go
yeah,
offline. Uh,
yes,
so Gajendra, I hope to see you for the remaining workshop and for the talks tomorrow as well. Uh,
yes,
so do stay with us. For the attendees, we will have a short, like 5-minute break since there are no questions. In case there are any questions, please ask them here, or you can also ask them in the specific workshop channel that we have for Indic NLP in the chat.scipy. I think Gajendra, you can just keep monitoring the chat.scipy for any questions that come up there. A
yeah,
few
sure,
people are also curious to understand if you can share your slides that you had. So
yeah,
if you
sure.
can just share it with us in the speakers channel, in the Indic, the
Yeah,
chat.scipy place, we can
yeah,
put,
I will share.
yes. So we'll put it up on the website and other places.
Yes,
Uh, And in case you are looking to interact with the attendees, you can sort of just move to the lounge area and stick to one of the lounge rooms. And
Okay.
usually if someone comes in, you can have a chat with them. If they want to ask any questions, I would encourage the attendees as well to sort of move to the lounge area. You can go to the lakeside room specifically,
Okay.
so that people can find
Okay.
you there. And they
Okay.
can chat with you there. They can even come up on screen if they want to talk to you and things like that.
Yes. Sure.
But yeah, so the lounge area is open for questions if people want to ask Mr. Gajendra there. The chat.SciPy workshop channel is also open. We will be sharing the slides, and we have the next workshop coming up in about 3 to 4 minutes, which is object counting in an image, object detection and marking by Deepak Kumar and Nalin Kumar. So thank you so much, Gajendra. Thank you, and we'll stop
Yeah.
broadcasting right now. Thank you.
Yes. Thank you, Ankit. Thank you.